Morning all, I'm Naren, assistant lecturer in the department in the subject basis electrical and electronics engineering. Today we are going to see about PN junction diagram. The content overview. In this PPT presentation, we are going to see about um, what is diode, introduction of diode, how a PN junction forms, operating principles of PN junction diode, key equation governing the PN junction, mechanism of the current flow through the junction, practical use of the PN junction diode, summary and final. So first, the definition. The PN junction represents the boundary or two distinct types of semiconductor materials, which is P-type and N-type, meet at a single semiconductor devices. This interface plays a crucial role in the behavior and the function of semiconductor components. This is a symbol of uh, this is a symbol of a semiconductor device, which is nothing but a PN junction diode. In PN junction, the PN junction in semiconductor is formed through the process called gating. On p-type side, there is a surplus of positive charges that is known as holes, whereas the n-type side contains an abundance of negative charges or electrons. A detailed explanation of the grouping technique will be provided in the following section. Um, this is the PN diode, where we have the depletion region with the holes, empty holes, and the free electrons. The formation of PN junction diode. When constructing a PN junction from a different semiconductor materials, a grain boundary typically forms. This boundary acts as a barrier, disturbing the free flow of electrons and holes by causing scattering. To overcome this obstacle and disseminate charge carrier moment, the technique of doping is employed. Let's explore how doping transforms a semiconductor using the practical example. Imagine a slender sheet of P-type silicon introducing a trace amount of pentavalent impurities into the sheet, cause a portion of P-type silicon to convert into N-type silicon. As a result, the sheet now features distinct P-type and N-type region, creating a boundary known as p-n junction between them. After p-n junction is established, two key mechanisms come into play: diffusion and drift. These occurs due to unequal distribution of electrons and the holes on either side of the junction. Holes from the p-type region migrate towards n-type side, while electrons from n-type region move towards p-type side. This movement generates a diffusion current flowing across the junction. Next, operation states of PN junction diode. No bias condition. Here, the diode is not connected to any external voltage source, so no voltage is applied across the junction. Forward bias condition. The positive side of the voltage supply is linked to the p-type semiconductor, where the negative side is attached to n-type, allowing current to flow. Reverse bias condition. Voltage supply negative terminal connected to the p-type region and the positive terminal connect to n-type region, preventing current flow across the junction. Behavior of p-n junction diode under forward bias. Forward bias occurs when the p-type semiconductor is linked to the positive terminal of the power source, while the n-type is connected to the negative terminal. In this configuration, the internal electric field at the junction opposes the external voltage supply, effectively reducing the barrier of charge barriers to cross the junction. This opposition between the built-in and applied electric field facilitates current flow through the diode. This is this is the process that happen on PN junction. Reverse bias in the PN junction diode. As shown in the above figure, the reverse bias occurs when P semiconductor is linked with the negative terminal of the power source, while N-type semiconductor connects with the positive terminal. Under this step, the internal electric field inherited to the junction and external electric field applied to the battery align in the same direction, reinforcing each other. So no current flows. This is the reverse bias, where the N is connected to positive and P is connected to negative. Application of PN junction diode. When reverse bias, the PN junction acts as a photo responding sensitivity to high text flow. It serves as a fundamental component in solar cells, converting sunlight into electrical energy. In forward bias mode, the diode functions as a light-emitting diode widely used in illumination. Additionally, it plays a crucial role as a rectifier in numerous electrical circuits and operates as a voltage control oscillator in character applications. Conclusion: a p-n junction diode allows electric charges to flow in one direction, but not in the opposite direction. That is, negative charge electrons can easily flow through the junction from N to P, but not from P to N, and the reverse bias is true for reverse. This is the reference. Thank you.